So here, let's say this is the entire track, and we are told that the first one, and I'll call that H1, horse 1, beats the second one by 11 meters. So that would be the distance when between the two horses when H1 reaches the end. And the third one would be somewhere here, and that distance would be 90 meters. So with these, if we say it takes time t for H1 to cover the entire course, and if H1 is the speed, and I'm also using the same descriptor, then H1t is d. That's the first relationship. In case of H2, it has traveled d minus 11 meters because it's at this point. And if its speed is H2, that would be H2 times the same time. And then finally for the H3, d minus 90 is H3t. Now this information I'll represent in a different schematic. The second beats the track is the same length. Second would be here, and then third would be, let's say, at this point, and that distance is 80 meters. Now this is a different time because I'll call that T2 because H1 has already reached that destination. The T2 would be greater than T. So the relationship here would be D is second horse's speed times this new time, and then for horse 3, D minus 80 would be his speed times that same time. The key thing is that I can divide these two out to give me a ratio of H2 over H3. And I can do the same here. You'll see you don't really need that one. And we'll get D minus 11 as D over D minus 90 is H2 over H3, because again here T would drop out. And if we equate these two, we have an equation with just one variable, which is the length of the race course. So this is our final equation, and since we don't have any answer choices, we can't even plug in. So we'll just cross multiply. So that becomes d squared minus 90d, this piece here, and then if I multiply these two, that would become d squared minus 80d minus 11d plus 880. And these two drop out. That's minus 91d. I'll move that over, and that would become 91d minus 90d, which is d, and that's exactly what I'm looking for, which is the answer.